Hello, this video is about the elasticity of demand, price elasticity of demand to be more specific, and what we look at here is how responsive consumers are when we change the price of one good in terms of the quantity demanded for that good. So again, the elasticity, the definition is the ratio of the percentage change in quantity demanded over the percentage change in price. Now, as an illustration, why do we use the term elasticity? Well, if you look at an elastic band and imagine that you want to change the price, so let's say you raise the price on one good, maybe ice cream, you want to know how consumers will respond in terms of their demand for ice cream. If you change the price by so much and consumers react a lot, we will say that the consumers are highly sensitive and therefore price elastic. However, if the change in price barely has any effect on demand, then we will say that consumers are not sensitive to that change in price and therefore their demand is inelastic. So let's look at this handout here where we have an example of one good, ice cream, and we are going to have different type of consumers at different point in time. So maybe we want to consume ice cream on a hot summer day, but we might also enjoy ice cream on a cold winter night, winter day. But before we look over those graphs, let's recap those different formula to derive the price elasticity of demand. So again, there's also the supply side for when we want to look at elasticities, but here we will concentrate and look at consumers on the demand side. So again, elasticity will always be a ratio of how, if I were to change the price, how will demand respond? So here we look at the ratio of the percentage change in quantity demanded over percentage change in price. That's the general formula where to derive the percentage change in price, we take the original price P1, we take the new price P2, we take the difference between the two, P2 minus P1 divided by P1, and we multiply this by 100. We do the same for quantity demanded, so we take the new quantity demanded after the change in price minus the old quantity demanded Q1 divided by Q1 times 100. Know that you can simplify this ratio by doing this. That's one way to calculate the elasticity of demand. The other way is to use the midpoint formula, and there is the rationale in the textbook that explains why we might want to use this method. But pretty much, you're going to look at the change in quantity demanded divided by the midpoint between those two quantities. So you do Q1 plus Q2 divided by 2, that will give you the midpoint. And you do the same for the price. So again, delta stands for change between P2 and P1. Here's the formula. So what we'll do here, we'll calculate the elasticities in three settings, three cases. The first one, we'll look at this graph here, the downward sloping demand curve for ice cream. The price of ice cream is here, and we want to see the effect of a change in price from $1.10 to 90 cents. So if I calculate the percentage change, I do the new price minus the old one divided by the old one times 100, I get a drop of 20%. Decrease in price. What will be the effect on quantity demanded? Well, at the original price, quantity demanded was 900 ice cream. At the new price, now we're here on the demand curve, quantity demanded is 1,100 ice cream. Okay? So now if I were to calculate the percentage change here, the 20% drop in price actually caused quantity demanded to increase by 20%. Okay? So that's what we did here. And I'm going to say this is maybe the demand for ice cream on a hot summer day. Now let's calculate the elasticity. So I'm going to use the midpoint formula, and I want to take the absolute value of this. So I'm taking the change in demand divided by the midpoint quantity demanded. So the midpoint would be right here, somewhere in the middle here, divided by the change in price divided by the midpoint price. So what's the midpoint here between $1.10 and 90 cents? And that's my elasticity. So when I do the calculation, I get this ratio. I want to take the absolute value, and I see that the elasticity is equal to 1. That is, if I were to reduce the price by 20%, quantity demanded will increase by 20%. 20 over 20, that's 1. If I were to increase the price by 20%, from 90 cents to $1.10, then quantity demanded will drop by 20%. If I were to lower the price by 3%, quantity demanded will increase by 3%. 3 over 3 equal 1. That's why we take the absolute value and we get this elasticity here. Now, second case here, the middle graph. If you notice here, the demand curve is much steeper. Okay? So here, maybe it's the demand for ice cream on a cold winter night. Maybe us consumers won't be too excited about getting a 20 cents discount on an ice cream. We might eat a little bit more ice cream because it's cheaper, but not by as much as if it was a hot summer day. So here quantity demanded only goes from 950 to 1050. So the increase is only 100 ice cream compared to 200 here in this case. So I want you to calculate the percentage change here and there. So again, here that's simple. It's still the same price drop. A drop of 20% of the price. You calculate the percentage change and you will find that a drop of the price of 20% increase quantity demanded by 10%. Okay? So as you notice here, 20% drop in price, the increase in demand is the same, 20%, but here it's only 10%. So going back to this elastic band, demand is much less responsive here to that discount, to that change in price. So here demand is more inelastic than this demand that is more elastic. Now, if you want a tip to remember the shape of a demand curve, that looks very steep, almost like the letter I of inelastic. Okay? So now let's calculate the elasticity. Again, the elasticity will be the percentage change in price, and at the top, the percentage change in quantity demanded. So we already know that was a drop of 20% of the price, and quantity demanded as a result increased by 10%. So if you take the absolute value of that number, you can simplify here, it is equal to 1/2. Or 0.5, which is less than 1, meaning that the demand will be inelastic, because every time you change the price by 1, quantity demanded will change by less than 1, here 0.5. Or another example, if you were to increase the price by 2%, quantity demanded will drop by 1%, not as sensitive to a change in price. So here we can say that demand is inelastic. Now over here, if you compare the first graph to the second one, much steeper, and the third one, now the demand curve is relatively flat, demand curve D3, we still have the same drop in price, 20%, but now if I calculate the percentage change here, it is more than 20%, it is 40%. So here I calculate the elasticity, I take the absolute value, the price dropped by 20%, and as a result, quantity demanded increased by 40%. If I take the absolute value of this number, I get a positive 2, which is greater than 1, meaning that every time, let's say, I drop the price, let's say by 1%, quantity demanded will increase by 2%. Demand is highly sensitive. Maybe it's on a very hot day, you give me a discount, I'm going to eat a lot more ice cream. So here, in this case, the demand curve is elastic. Okay. Now let's look at the effect of consumers being more or less sensitive to a change in price on the firm's revenue. So I did a couple of graphs here. One demand curve is much steeper than the other. This is steep, this is flat. So again, that looks like the letter I, so we can guess that here the demand curve is inelastic, and here the demand curve is elastic. what will be the effect on the firm's revenue? So to calculate the firm's revenue, if we look at graph A here, revenue will be the price that you sell, the price of that ice cream, times how many you sell, P times Q. So if I were to look at this on the graph, the price is $1.10 that you get for each one of those 950 ice cream that you will sell at that price. For the first one you get $1.10, for the second one, the third, and up to the last one. So all of this, that's your revenue, P times Q, $1.10 times 950. Now after you give the discount, the price is lower, so the new price is 90 cents times more ice cream, because now you've got an additional 100 ice cream sold. That's your new revenue. Okay? Now what do you see in common here? There is box number 2 here. It's always revenue, because you always make 90 cents even when the price was $1.10, but now you sell more. So that's common. The only difference here is, because you get a discount, you're gonna lose some money on the first 950 ice cream you sell. You're gonna lose 20 cents. $1.10 minus 90 cents times 950. So you're gonna lose this much revenue. That's gonna be a loss. But at the same time, since you sell an additional 100 ice cream at a lower price, you're gonna get 90 cents times 100. So you're gonna gain all of this. So the change in revenue is, you're gonna lose this, but you're gonna gain this. You lose area 1, but you gain area 3. So let's calculate total revenue before and after the price cut. So look at that graph and then move over here. Total revenue before the price cut was that big pink box, area 1 plus 2, that's 1045. After the price cut, you look at the big yellow box, it's area 2 and 3, and it's $945. So what happened here? When you cut the price, when demand is what? Inelastic, okay, very steep curve. So if you give a discount and your consumers are not very sensitive, what's going to happen to total revenue? Well, total revenue will drop, will go from 1045 to 945. Okay, so you might not want to give a discount if demand is inelastic. Now, looking over here, we have a different case where demand is more elastic. Okay, so maybe that's on a hot summer day, you give that discount. Yes, I'm going to buy and consume more ice cream. What will be the effect on total revenue? Again, total revenue before was $1.10 times 800 in this case. That's total revenue. Total revenue after is the new price, so you sell at a lower price. That's going to allow you to sell more. That's your new total revenue. So you're going to lose this box here. That's a loss of revenue, but you're going to gain area 3. Okay? So let's calculate the change in total revenue. What is total revenue before the price cuts? That's going to be $1.10 times 800 ice cream. That's $8.80. What about after the price cuts? 90 cents times 1200, that's $10.80. So clearly here, when you give a discount and consumers are sensitive to that discount, they're going to consume more, you're going to make more money. So cutting the price when demand is elastic will increase total revenue. Now I would conclude with this. Here we talked about giving a discount, a decrease in the price. But what would happen if you increase the price? You will have different conclusion. So for practice, please do the opposite case. Instead of a drop in price, let's see what happens when we increase the price when demand is elastic or inelastic.